And today I'm just going to go through a brief presentation on NetScaler and what value it brings to businesses and organizations. So without further ado, I'm going to go ahead and move right into my first slide here. So just really quickly want to lay a little primer here, so to speak. Probably a lot of you already know this, but this is just a good foundation to start on. Back in the 90s, we really had client-server type technology where we would make requests to servers, and obviously we all understand the problems with that is that we have a single point of failure most of the time in that scenario. Servers can be overloaded, so on and so forth. And so that quickly got replaced or optimized with load balancing in the early 2000s, turn of the century. So this is where we saw a lot of the load being distributed across multiple servers on the back end. So requests came in, hit the load balancer, and then they would be load balanced to the various resources in the data center. So that's kind of what load balancing brought to the table. Very basic functionality. But today, what the market is demanding and where the market is actually really on fire is with the application delivery controller space. And so I'm going to dive in today on specifically what an application delivery controller is. And NetScaler happens to be an application delivery controller. Oftentimes I hear that NetScaler is as a load balancer, and yes, that's about 15 to 20% of what it does, but it's only just a small portion. So that being said, let's just kind of really quickly just look at the traditional load balancers that happened around the turn of the century. Again, they would maintain user sessions. They distribute the traffic across multiple resources within a data center. And at the end of the day, I mean, it's all about application servers and users getting to the information that they need in the data center. And so if they're not able to get there, then that's a huge problem, of course. Back in the early turn of the century or in the 90s, we basically, having remote access to information and resources was a luxury. Today, it's now expected, as we all know very well. So that being said, we can send traffic and distribute traffic with traditional load balancers, but there's problems with that. And so that's why ADCs or application delivery controllers, and by the way, as I go forward, I'm going to use the acronym ADC for application delivery controller. So basically, application delivery controllers went ahead and started to prevent things like this. This is an example of a website that I went out on with my son after a Monday Night Football game. My son loves cars, and he wanted to check out Jaguars. And I started hitting Jaguars' website, and I started getting these status 500, HTTP status 500 errors all over their website. So I got to imagine that if it's after a Monday Night Football game, people have been, hanging out and stuff, and they do this, they're not going to want to have to go to a website shopping for a car and have this type of activity going on the website. This is costly, I would imagine, to businesses. So this is just one example of where a load balancer would have sent the traffic to the back-end resource, but it didn't really check the health all the way up to the application level. So with an application delivery controller like NetScaler, what we're doing is we're actually doing real-world tests against the application all the way to layer 7. What I mean by that is we could actually look for the text on the web page in this scenario that we're expecting to see, or even look at the HTTP status code that comes back from the server and know, hey, this server on the back end is not healthy, and therefore not route traffic there, because that, of course, is not going to produce optimal results. The other thing that we've seen in the news, for example, Target, they had their customers were hit with a data breach as of late, and also Michael's, another retailer, payment card breaches. These things are plastered all over the news. And healthcare.gov is another example of being out of reach for customers to get in there and register. And then a perfect example that I remember clearly is in 2007 when the Rockies made the World Series, and everybody hit the website all at once to get tickets when they put tickets on sale, and it took the website down. So these are all examples of where an application delivery controller like NetScaler can absolutely prevent and ensure that the end users that need to be productive are able to get to the resources that they need to get to. And oh, by the way, they're getting there securely, and they don't have to worry about having security breaches such as Michael's and Target. And we'll dive into a little more of how that's taken care of from an ADC perspective later. But I just wanted to kind of use some real-world references to scenarios where ADCs would absolutely have a big impact on these types of situations. So just to be clear on where an application delivery controller resides in the data center and how it relates to the network is that most routing and switching is working down at layers 1 through 3 in the OSI, actually 1 through 4 to be specific. And then the NetScaler or application delivery controllers, they reside in the upper tiers of the OSI. Of course, they have to connect to the network and use the lower levels of the OSI. But really what we're doing is we're bringing intelligence into the network infrastructure. What I mean by that is we're absolutely doing things that not only send packets like a router and a switch to destinations does, but also making sure that when we send those, we're doing it intelligently. So let's dive into what that actually means a little bit. So these are the areas, 4 areas of an application delivery controller. If I were talking to a C-level or somebody that wasn't very technical, I would say these are the things that an application delivery controller is going to bring value to your data center or to your business. It's going to bring availability, performance, offload, and security. So let's dive into these 4 areas quickly here and just take a look at what that actually means. So the NetScaler ADC is a world-class load balancer. That's where it got its roots. Basically, Citrix acquired NetScaler probably 8 years ago, and it was a world-class load balancer at that time. Being an ADC, health monitoring is of utmost importance. So what I mean by that is that we are sitting in the line of traffic between the applications and the users that are requesting the information they need to do their job or be functional or whatever it is that they're doing, whether it be online transactions, procurement of books, whatever it is they're doing, or business. Basically what we're doing is we're sitting in line of that traffic. So in your data center, we would by default be a reverse proxy into these resources. So we have the ability to actually go out and talk to these resources and do synthetic transactions against those. Whether those transactions, whether those items in the data center are DNS, whether they're web services, whether they're SQL databases, I can go on and on. Pretty much anything in your data center, FTP, TFTP, all of those protocols, we can actually sit in front of, and we can do synthetic transactions against them. So an example would be load balancing DNS. We could actually do synthetic DNS lookups against DNS servers that we have behind the NetScalers and ensure that we're getting layer 7 true DNS resolution before we send requests there. And oh, by the way, unlike traditional DNS, sends everything to the single server until the backup is needed. When you have 2 or 3 different DNS servers assigned, we can actually distribute that load across all the DNS servers. Just a quick example of our world-class load balancing. The other thing is, from a performance standpoint, I'm going to move over to this square here, where we're talking about, hey, look, if I've got requests coming in, and for example, the ticket's going on sale for the Rockies, and I have to retrieve the information from the data center servers, why not, if it's static content that's not changing, why not go fetch it once and cache it here on the NetScaler and serve it up thousands, if not millions of times back to the end user request? Makes perfect sense because then we don't take these servers down. They're not burdened with every request, and the NetScaler is actually able to serve those up quickly. So we're actually generating a performance increase, and the user experience is enhanced. Over here, this square right here is basically the offload, and this is where we get our return on our investment in an ADC such as NetScaler. So what do I mean by that? SSL, which is pretty much all over our data centers now, it's the encryption that protects the information that's going across untrusted networks is oftentimes done and performed encrypted and decrypted on the back-end servers in your data center. That being said, that's a very taxing process, especially since most certificate authorities are requiring a minimum of 2048-bit certificates. So the processing and the overhead with that is pretty substantial. NetScaler has a hardware coprocessor. It's a Cavion chipset. Its whole role in life is to basically encrypt and decrypt traffic, SSL traffic. So what we do is we terminate the SSL traffic here, we read it, and then we send it back on native traffic or standard HTTP to the back-end servers. So what happens is the NetScaler inherits all that heavy lifting of the SSL. Now, if you require having SSL all the way through from the start to finish to the back end, we can certainly do that. We can also decrypt the traffic and then encrypt it again and send it to the back-end servers after we do maybe some web application firewall inspection. So it's not a requirement, but it's definitely a way to leverage the NetScaler to get some return on your investment. The other thing to keep in mind is that while there may be thousands, if not millions, of connections coming into the NetScaler will in turn establish limited connections, single connections to the back-end servers, and reuse those single TCP connections over and over again for these millions of connections to come in. So what ends up the result of that is that these servers are not having to tear down and bring up TCP connections, which has a substantial amount of overhead on back-end servers. The end result here is that these data center servers are absolutely doing what they're supposed to be doing. Mail, web, whatever it is that they're doing in your data center, they're doing that instead of all this heavy lifting. And then finally, from a security perspective, NetScaler is a world-class web application firewall solution. Citrix made an acquisition several years ago of a well-known web application firewall company called Teros, and then we baked it into our NetScaler ADC solution. And it makes perfect sense because if we're load balancing the traffic, we're terminating the traffic, and we're reverse proxying the traffic into the data center, why not take advantage of a web application firewall, not a network firewall, but a web application firewall, to do inspection for SQL injection attacks, XML attacks, anything that is known as an attack on IIS, Apache, whatever it is that you're hosting up in your data center, why not avoid those? And oh, by the way, why not look for unexpected responses from clients so that we can be protected on those day zero attacks that are potentially out there? So this is where NetScaler would really play a part in preventing potentially those things that target Michaels and some of the other websites that we read about in the news. So we're able to inspect that and make sure that we're trusting that traffic so that it comes through when it comes through. So an ADC is basically load balancing on steroids. I already said that and referred to that a little bit here. But basically, we're able to bring intelligence into how we send things to the back end, to the servers. Another example that I just want to refer to here, ADCs are load balancing on steroids, is that if you have multiple languages, we can actually look at the request for an HTTP website that comes in your data center. If they happen to need English, French, Spanish, whatever the language is, why ask the user for that information? Why say what language would you like to speak on your website as you enter our site? Why not just read the request and actually send them there on their behalf? Because the information is already there in the HTTP request. Another example of ADC load balancing on steroids, if you've ever been on an iPad or a tablet device, visited a website, and it asks you if you want to install the app rather than visit the full site. That's a perfect example of an ADC in front of a website that actually read the request and brought intelligence to that request and said, hey, look, we got an app. You want to install it? Instead of actually hitting the website and getting a traditional PC or Mac type of experience, why not give you the tablet experience or the mobile device experience? So those are just a couple examples. I talked about availability early on, and we talked about making sure that things get to the back-end data center resources. That was all basically talk about a single site, but NetScaler actually brings multiple site availability. So we can actually do active-passive or proximity-based load balancing across data centers across the globe, whether there be 2, 3, however many data centers that are in your infrastructure. We can actually bring intelligence to that traffic and distribute that load across those data centers. So in this scenario, basically, as an example, what we see in most enterprises is there's primarily a site A where users will come in for connectivity. That site happens to go away, or we muck up the firewall at that particular site and nobody can get to it, let's say, or something goes on. We can actually intelligently, via basically manipulating the record that gets returned from DNS, direct that traffic to an alternative site. This is our global server load balancing functionality. Again, bringing intelligence into the upper layers of the OSI model. So just to recap, reducing the load on the servers, SSL gets terminated back to the back-end data center servers, and then we also do TCP multiplexing, which we've referred to where there's less TCP connections going to the back-end servers. So the result is supports greater user capacity, so you're actually going to get more out of your virtual infrastructure or your server infrastructure in your data center because of this. This is the return on the investment. We accelerate the applications. Again, just to recap, we can basically cache things. We can actually take care of the compression that goes out to the clients via HTTP compression on the NetScaler on behalf of the back-end data center servers, and take care of that quickly and get that back to the end users so that their experience is absolutely the best that we can possibly deliver. The integration of the application firewall, as I kind of alluded to, just to recap, it blocks dozens of day zero attacks, right? So basically those that we don't know about. We also mirror snort definitions that are out on the internet for known security vulnerabilities. We're ICSA certified, and then we can also decrypt the SSL traffic and then encrypt it again once it's been inspected and send it to the back-end data center servers if that's required. The last thing, or one of the last things I'm going to be talking about here is basically going to be analytics. Because we are in the flow of the traffic or the communication between the end users and the data center's resources that you're trying to access, there's a tremendous amount of analytics that we can go after with that traffic. So basically we can understand, was there latency or was there, a delay in the amount of time going across the WAN to get to the actual client, or was there data center latency, was there server latency? We can start to measure round trip times, render times of web pages. All of this information becomes available to us so that we can start being proactive in understanding the user experience. Specifically, if you are a Zen app and Zen desktop customer of ours, we can actually bring a tremendous amount of understanding into that traffic and the user experience. And if somebody calls into the help desk at your organization and says, hey, look, things are slow, we can now start to dive into that through our HDX Insight technology that we have with our NetScaler product to understand where that breakdown is. So it brings a tremendous amount of visibility into the user experience and allows us to be a little more proactive with their experience coming in and out of the data center. So just again, these are the things ADCs basically bring to the table. One of the things that I just want to make sure that we hit on quickly here is the centralized certificate management. If we're terminating all the SSL on this ADC, and we're talking native ports to the back-end servers, our management of SSL certificates becomes centralized, and the NetScaler can actually let your organizations know when those are going to expire. We can set traps to basically alert the IT organization 30 days out, 45 days out, whatever makes sense to ensure that there's not an outage for certificates expiring. I hear that as a problem in a lot of the organizations that I'm in front of constantly. But basically, a lot of this is just basically summarizing what a NetScaler ADC brings to the market.